จากในหัวข้อแรกนะคะที่เราได้พูดถึงภาพรวมกันไปแล้วค่ะมาถึงการสัมมนาในหัวข้อต่อไปช่วงนี้ค่ะเราจะมาเจาะลึกถึงบทบาทในการสร้างความเปลี่ยนแปลงในอีโคซิสเต็มของชุมชนเมืองไปสู่ภาคธุรกิจกันค่ะกับหัวข้อ From City to Business Transformation Adaptation และขอเชิญทุกท่านพบกับ Professor Johan Rockström Director Potsdam Institute for Climate Impact Research Germany ค่ะ
So dear friends, colleagues, resilience is on every decision maker's horizon today at the recovery phase from the worst lockdown of human health and economy since the 1930s as a result of the COVID-19 crisis. Resilient cities is absolutely fundamental to this endeavor. Scientifically, we know that we've entered a whole new geological epoch. We're deep into the Anthropocene. We're the prime driving force of change on the entire planet. We also have overwhelming evidence that this is causing shocks and stress way outside of the environmental domain, like, for example, the evidence that zoonotic disease outbreaks with virus spillovers like COVID-19 is a result of human penetration and degradation of ecosystems, wildlife markets, wet markets, global trade in a hyper-connected world. We see increasingly how people and planet collide with each other under unsustainable premises, causing outbreaks of the kind of diseases we see right now. But this is just one crisis in a predictable situation that we're facing. Now, what I will do here is give a scientific update on the challenges we're facing, but then also transition into what does this mean for sustainable, resilient city development. 2020 is, of course, a year of the COVID-19 crisis, but let's not forget it started with the unprecedented forest fires in Australia, causing social and economic and biodiversity havoc in Australia, but also releasing 900 million tons of carbon dioxide into the atmosphere, more than twice as much as the annual emissions from Australia over a whole year. This is a year when Siberia has had 38 degrees Celsius of temperature, unprecedented extreme, causing permafrost thawing, disease outbreaks, and accelerated melt of ice and forest fires. We have a record low again on Arctic sea ice loss. We have a record low again on Greenland ice melt pace. We have another bleaching event in the Great Barrier Reef, the third one in 5 years' time, 50% of the largest coral reef system in the world, adjacent to a whole set of coastal cities depending on this natural asset for its economy, is today beyond the tipping point of no return. We have floods in Bangladesh affecting millions. We have droughts in East Africa affecting millions, linking with COVID-19, a situation where desert locusts coming in and drought causing food insecurity and food riots exactly at the moment when you want to have social distancing and harmony to deal with the health outbreak. The Anthropocene is a turbulence point where we today need to navigate a future where surprise and shocks and stress are part of normality. As if that was not enough, we need to also recognize the risk of crossing tipping points. Here is what I would argue one of the most humbling scientific progress graphs we have today. This was published by my colleagues at the Potsdam Institute, Matteo Willett and colleagues, showing the last 3 million years, the Pleistocene geological epoch, and the first time a fully configured climate physics model is able to reproduce the cycling between ice ages and warm periods during this entire geological epoch, showing, as you see in this graph, that global mean temperature, according to this analysis, has never exceeded 2 degrees Celsius warming away from the pre-industrial global mean temperature. This is an enormously important piece of information proving that the Earth system has this self-regulating physical and biological capacity to equilibrate even despite pressure points from orbital forcing and volcanic eruptions and earthquakes to stay within very narrow limits. We're today on a journey that will take us to 3-4 degrees Celsius warming in just the next 80 years. We're at 1.2 degrees Celsius warming. We're starting to see the impacts. In fact, it's just 2 years ago that we published a paper suggesting that the scientific evidence shows that we are at risk of drifting away from the last 12,000 years of stability on Earth, the Holocene, that the Anthropocene, today a pressure point, may push us into unstoppable drifting away to points that could potentially threaten the ability for us to really give even the minimum livelihood opportunities for a world population today at 7.7 on its way to be 9-10 billion people. We showed in a recent update following this Hot House Earth paper, just before the COVID-19 crisis took hold, that we have knowledge of 15 big tipping element systems in the Earth system, large biophysical systems that regulate the state of the planet. Results that were presented the first time, 2008. This was the 10-year update, and what you see here is a graph of the evidence that 9 of these 15 systems are starting to show signs of variability, of moving in directions that really should make us concerned, not that they have crossed tipping points, but that they are moving dangerously close, too close for comfort, to tipping points. But not only that, the scientific evidence has come so far in our understanding of the function of the Earth system that these are interconnected, that you have teleconnections, which means that Arctic sea ice accelerated melt affects the overturning circulation of heat in the North Atlantic, which in turn is connected with the South Atlantic or the southern parts of the hemisphere ocean system, affecting the West Antarctic ice shelves, accelerated ice melt, how the Atlantic affects the functioning of the whole precipitation system of the monsoons in the Amazon, which in turn can impact droughts and forest fires and carbon release in rainforests, meaning that not only are we at risk of crossing tipping points, causing unstoppable drift, but also that these are interconnected as dominoes that could self-reinforce each other. So that's the reality. You may pose the question, is this just one research group suggesting that we are coming close, too close for comfort, to these unstoppable tipping points? Well, the IPCC, the Intergovernmental Panel on Climate Change, the kind of minimum common denominator of scientific understanding on human-induced climate risk, has actually been supporting the same conclusion. Here you have a document which I would argue is perhaps the most important summary we have from 2019, last year, the United in Science document, coordinated by the World Meteorological Organization together with IPCC and Future Earth. And what you see here is the famous red embers diagrams of risk. The darker the red, the higher is the scientific risk of occurrence of negative outcomes. What you see here is each column is one IPCC assessment. So furthest to the left you have the 2001 third assessment, then you have the fourth assessment, the fifth assessment, and to the furthest right is the 1.5 degrees Celsius report of 2018. This is 19 years of scientific advancement. The cluster to the furthest left is impacts on big biomes and ecosystems. The cluster in the middle is extreme events, droughts, floods, etc. And the cluster to the right is the one of deepest concern, namely crossing tipping points, large-scale discontinuities. And just step back and look at the trend line. The trend line is very clear. The more we learn, the larger is the risk, meaning that the dark red risk goes down in temperature, because the y-axis here is deviation from global mean temperature before the Industrial Revolution. So you have a zero line to the furthest to the bottom. 19 years ago, the assessment was that the risk for large-scale discontinuities would not be at high risk until we reach 5-6 degrees Celsius warming. Basically, a non-risk. We were not on that trajectory. Today, the risk of crossing large-scale tipping points is assessed somewhere in the region between 2 and 3 degrees Celsius warming. Corroborating and supporting are tipping elements and the Pleistocene assessment that I showed earlier in the talk. Now, that is why we just half a year ago, and just a few months, no, it's now 9 months ago, but just a few months before COVID-19, put forward, together with the Club of Rome as a scientific community, the proposition that we now must consider declaring a state of planetary emergency. A planetary emergency state is not something we do lightly, of course. It is a combination of scientific risk assessment, the risk of crossing tipping points of irreversible change. We have the latest scientific assessment showing that every 1 degree Celsius of warming would potentially make 1 billion people on Earth be hosted for their livelihoods in uninhabitable areas, just from a pure body physiological perspective. the risk patterns. But the second point making an emergency really important to recognize is that we're running out of time. We've entered the decisive decade when the IPCC showed that we need to cut emissions by half over the next 10 years. This is the transformative moment that requires massive changes for humanity. So this is the entry point towards a resilient city agenda. Now, just to kind of close this in terms of where we are today, to come back to the point that the climate crisis is not an isolated crisis. It is connected to the health crisis and to an ecosystem crisis. We know that the final battleground, whether we will fail or succeed with delivering on the Paris Climate Agreement of staying well below 2 and aiming for 1.5, is whether we're able to sustain the carbon sinks in natural ecosystems, in the oceans, ice, and land, all the land-based ecosystems. But we also know that the health crisis right now is a zoonotic virus spillover related to connections between wildlife, domestic animals, and humans in the sustainable or unsustainable interactions between ecosystems and human societies in urban settings in particular. Now, the urban challenge, of course, is prime to whether we will succeed or fail in deviating away from unstoppable or unmanageable risks. 60% of the world population live in cities or will be living in cities by 2030. We're at 55% today. We're moving towards 75% by 2050. This is an urban, primarily coastal world we live in. That's the modern world of the 21st century. We also know that we today have a projection of 33 megacities, cities with more than 10 million people. The number was just at 10 cities as recent as 1990. We also know that we have something like 900 or 800 million people living in shanty towns, really the poor urban dwellers, a massive challenge for health, for security, for development into the future. We know that urban areas are the nodes for economic development and health and prosperity into the future. We also have increasing scientific evidence of the challenges facing urban areas. Here you have a kind of a popularization of really important research showing the challenges in terms of different regions of cities facing heat waves and water scarcity in yellow, cities facing floods primarily in green, cities facing warm heat wave temperatures even in the northern hemisphere. These are challenges that each city needs to incorporate in its own risk assessment to be able to navigate the future. We also have increasing projections of analysis of city challenges. This is work led by Shumei Bai from Australia, showing the key research challenges from observations of urban health and sustainability, data, understanding climate interactions with infrastructure and human behavior, how urban areas are connected to rural areas, what kind of transformations we need in terms of design of cities, but also, as shown to the right, the massive challenge we have. I mean, the overall estimates is that roughly 2/3 of the urban areas we need in the world by 2050 are not even built yet. This is the grand challenge, but also the grand opportunity. This one way of expressing it here is on the x-axis, the number of cumulative people living in urban areas. Today we are at number 4 there, developed countries emitting 53 gigatons of carbon dioxide and developing countries roughly 40 gigatons. But the gray voids here show that if we just let business as usual continue as today, developing countries would increase with another 109 gigatons of carbon dioxide emissions from just the urban development over the next, the next 30 years. And just the future growth of world populations would add another 100 gigatons of carbon dioxide. And remember that the global carbon budget remaining for us to stay at well below 2 is something like 300 gigatons, which means that just the urban development, if allowed to continue, will basically eat up the entire global carbon budget. Now, this is something that scientists need to engage with even further to really work on the transformation in cities, and this is something that is fundamental and is increasingly being highlighted, for example, here in Nature. We have the drama around the fact that we are facing a future where parts of the world may no longer be inhabitable because of the heat wave, drought, disease, flood patterns we are seeing increasingly being extreme in historic terms, but now being part of normality. The latest assessment being that a 3 degrees Celsius warming could threaten up to 2-3 billion people living primarily in the zones seen here, which are the unsuitable areas in the arid, semi-arid zones that would become even more challenging for people to survive in. Sea level rise is a massive threat because urban areas are often along coastal zones. We have a projection of up to 1 meter sea level rise in the IPCC, but we also know that the rapid ice melt in West Antarctica, the rapid ice melt in Greenland, the rapid temperature rise with thermal expansion leads to conclusions today being with a very wide range of uncertainty, where you have estimates that can take us to 2 meters in just the next 80 years. We're talking of shifting, from adaptability to transformability steps. And these are challenges that every urban area in coastal zones must now address very seriously. We also have these interconnections of health pandemics in an urbanized, globalized world. I've already referenced that. I think this is one of the major components of resilient city development, to be able to very quickly address redundancy, modularity, connectivity, the fundamental attributes of resilience building. When a shock hits in one part of the world, how does it propel across the world, and how do cities handle having an open borders for wealth and communications and food trade, for example, while at the same time avoiding health outbreaks at the local level. One of the fundamentals here in terms of climate, health, and urban development is, of course, air quality. The old environmental challenge, which is coming back as a fundamental challenge, both because we're not solving it properly with the PM 2.5 and PM 10, but also tropospheric ozone and nitrates and black carbon and sulfates, but also because we see so strong connections in a world that will be even more urban, but also increasingly potentially subject to the kind of pandemics that we're facing right now, that are viral infections in our lungs. And that lung capacity, which is directly related to air quality, may be a determinant factor of mortality in these pandemic situations. 5 million people die prematurely because of air pollution today. That's just almost an impossible number to digest, given that COVID-19, currently a devastating shock to human health across the world, has so far led to 750,000 people losing their lives. We are in a situation that is affecting, of course, developing countries most, but also in rich parts of the world, air pollution continues to be a killer and a premature dilemma for development. So here we have a perfect example of urban resilience opportunity to connect decarbonizing the energy system, air quality improvements, and thereby getting win-win outcomes on health as a conglomerate of investment for sustainable, resilient urban development. Now, COVID-19 was an effect of air quality improvement, a kind of a paradox in the whole outcome, and you've probably seen these data on the very significant reduction of air pollution. So smog suddenly disappearing in big cities around the world. Now, is that something to celebrate? The answer is no, because the pathway towards a sustainable, healthy future, towards resilient cities, is not by locking down and destroying the world economy. What we need to find is economic development which is functioning in harmony with people and planet, which can enable to create the next level of modernity, the next level of resilient, livable cities that are aligned with sustainability criteria. So this is where we are heading. And the link between COVID-19, air pollution, and climate, I think could be an area, or should be, must be an area of deep learning for transformation into the future. Now, When it comes to rising temperatures, this is going to have massive effects on infectious disease outbreaks, and we're seeing this as an even larger threat than pandemic outcomes into the future, and that also has to be recognized very, very seriously. Now, all of this takes us to a point of raising the question, what's the paradigm that can now transform us towards a resilient city future? Well, the paradigm must, I would argue, connect the deep insights that we are in the Anthropocene, the deep insights that we are bouncing at the ceiling of the capacity of the planet to remain stable, that we are at a point of transformation when it comes to returning towards a safe operating space on a stable and resilient Earth system, that tipping points are real, and that crossing tipping points means pressing on buttons for irreversible change that would hand over a very difficult life situation for all future generations. And if you combine these insights, you need something like a planetary boundary framework, science-based targets for a safe and just space for humanity on Earth as a guiding post, as a scientific guardrails or boundaries that can help development in cities, in businesses, in communities, in economic sectors across the world. So the planetary boundary framework that tries to define scientifically the big biophysical systems that regulates the stability of the planet, and quantitatively defines the boundaries that gives us a safe space, shown here in green. You go beyond that safe space, you enter in yellow the danger zone of uncertainty, where you start seeing things changing in a worrying way. And as you see, we are actually for climate, for biodiversity loss, for overloading of nutrients related to agriculture, producing food to urban areas, creating waste and eutrophying downstream rivers and groundwater and coastal zones of nitrogen and phosphorus, and land use change. We are already in situations of danger, and we're seeing the evidence playing out right as we speak. So this is, I would argue, one element of a narrative and a framework. Science-based targets for urban development can be a key tool for resilient city development. And we have the Science-Based Target Network today, we have the Science-Based Target Initiative on climate, we have the Global Commons Alliance trying to recognize the fact that every city in the world today depends on the stability of the global commons, the rainforest, the temperate forest, the coral reef systems, the ice sheets, depending on these for our own outcome in our own city, wherever that city is on planet Earth. Working with Jeff Sachs and the Sustainable Development Solutions Network to support the Sustainable Development Goals, we've identified the 6 transformations for delivery on the Sustainable Development Goals within planetary boundaries. These 6 transformation areas come as no surprise for anyone involved in resilient city development, including decarbonizing energy systems, including innovations for construction and infrastructure and planning, new mobility pathways, a digital revolution, investing in education, a transformation of the food system, and urban areas are fundamental here, not necessarily in terms of producing food, but in being part of the system, in terms of the connections between the farmers producing the food and how we close the loop on biomass, nitrogen, phosphorus, water, to be able to have a harmonious cyclical system instead of the linear destructive system we have today, where we take out nitrogen, inert nitrogen from the atmosphere, create through energy intensive Haber-Bosch process reactive nitrogen for fertilizers. We fertilize our crops, we ship them into urban areas, we consume it, we create waste, and we download it downstream and destroy groundwater, coastal zones, and freshwater systems. This is a completely unsustainable system which is threatening the stability of the planet. We have actually even translated the planetary boundary science into different tools for the pathways to follow. One of them is the carbon law inspired by the Moore's law, a law that says If you take the IPCC assessment shown here, we need to bend the global curve of emission by 2020, so this year, and then follow a path, as you see here in green, which is the emission reductions path, to be able to have a 66% chance on delivering on the 1.5 degrees Celsius target. This is a decarbonized world economy in 30 years' time. And it translates to the following trajectory. In gray here, you see the energy transformation globally. It is in par with cutting emissions by half every decade. So that's the carbon law. If we can cut emissions by half every decade, from 40 gigatons of carbon dioxide today per year to 20 by 2030, to 10 by 2040, to 5 by 2050, with a little residual left there, which is probably necessary for some mining activities like steel production and some heavy industries, then we have a chance of following the necessary path. The interesting thing with the carbon law is that it can be scaled for any sector, any geography, any city in the world. Anyone can take on board the carbon law. And my advice would be, apart from the framework on planetary boundaries, would also be to adopt a framework on the carbon law. Now, the carbon law will not take us all the way. What you see in this graph here is also that we have to maintain what is shown here in green and blue, which is the negative carbon sinks in nature. Protecting nature is an urban priority. In orange here, you see the transformation of the food system from brown, a major emitter, to orange, a major carbon sink. Sustainable food consumed in urban areas, originating from sustainable landscape management with carbon sinks and biodiversity-rich production systems, is a key to success. What you see in yellow is the carbon capture and storage requirements to be able to have a chance to do this. Carlos Moedas, when he was the European Commissioner for Energy and Climate, led the work on a very important report for Europe on this pathway, showing the governance, the technologies, the investments required to succeed in building resilient cities. We have the German Global Change Research Group, the WBGU, the German Advisory Council on Global Change, which has also produced a flagship report on resilient urban transformations, showing sector by sector what is required or the opportunities for resilient urban development, showing how circular business models, novel building materials, being brave and courageous on investing in infrastructure for decarbonizing mobility, the whole area of digital, big data, AI methodologies for different types of transmission systems for electricity and battery charging, for example. All of these innovations that can play in favor of resilient urban development. We have some colleagues and my predecessor as director of the Potsdam Institute, John Schellenhuber, addressing quite recently the challenge of how to transition one of the major sources of greenhouse gas emissions, namely conventional cement construction, into wood-based construction, which would be a tremendous transformation thanks to transitioning from emitting system cement to carbon sink systems, namely wood. This is, of course, a question of integrating with the entire carbon cycle of urban areas, how urban areas are not isolated islands, they are connected to their wide system landscape from food production, biomass, construction materials, energy fluxes across very large geographies. This Buildings as Global Carbon Sinks, led by Galina Churkina, shows very closely what an enormous opportunity it is to reduce emissions from the building sector from something like 5 gigatons of carbon, which is like 15 gigatons of carbon dioxide, which is like, something like 2-digit % of global emissions, down to being essentially a net zero sector in society, a tremendous opportunity. So, just to round this off and also to hand over for this really important forum here, I think one kind of framing guide, which I hope I've been able to convey scientifically, is that the planetary boundary framework is required today to navigate a future of increasing surprise and shocks and stress being part of the Anthropocene reality, that we have to place human well-being, prosperity and equity, the Sustainable Development Goals, inside the safe operating space, and that this is a framework which is not an environmental agenda for protection, it is an agenda for human development on Earth. And given that urban areas will be are dominating already today, I would argue this is one of the biggest pieces of the puzzle for us to succeed in our future on Earth. So thank you very much, and good luck into this very important forum.
ขอบคุณ Professor Johan Rockström นะคะที่ทำให้เราได้ทราบถึงแนวคิดการเชื่อมโยงของชุมชนเมืองไปสู่ภาคธุรกิจเพื่อสร้างความยั่งยืนในอนาคตค่ะ
ค่ะและตอนนี้นะคะเราจะพักกันสักครู่ค่ะแล้วกลับมาพบกันในช่วงหน้ากับหัวข้อ The Agents of Change Next Generation Voice ค่ะ